Hello students, welcome to Unacademy. Dr. Khalil here, welcoming you to operating system course नया आगाज सीरीज। तो आज का जो टॉपिक है सिंक्रोनाइजेशन कंटिन्यू करेंगे फ्रॉम द प्रीवियस सेशन। So recollecting the previous session, we have seen what is the need for synchronization, what are the problems that arise due to lack of synchronization, and then essentially हमने define किया the problem of critical section। तो आज just trying to review कि देखेंगे आगे बढ़ते हुए। सबसे पहले हमने देखा कि व्हाट इज द नीड फॉर सिंक्रोनाइजेशन इन एनी आईपीसी एनवायरनमेंट व्हेनेवर प्रोसेसेस कम्युनिकेट द कम्युनिकेशन इफ इट इज नॉट कोऑर्डिनेटेड देन इट मे लीड टू प्रॉब्लम्स। कौन से प्रॉब्लम्स हो सकते हैं? द प्रॉब्लम्स कैन बी लाइक इनकंसिस्टेंसी और समटाइम डेटा लॉस एंड इवेंचुअली processes in the worst scenario may end up getting into a deadlock. So none of these are the requirement, are the desirabilities of IPC environment. We never want inconsistency, we never want any data loss, we never want any deadlock to happen. So क्या करना चाहिए? In that regard, we say processes must be well coordinated, processes must have an agreed upon protocol so that they don't enter into any such undesirable situation. Then हमने पढ़ा कि synchronization is of two types: competitive synchronization, cooperative synchronization. Two or more processes are said to be in competitive mode if they compete or contend for the accessibility of any shared resource. And we said two processes are cooperating if and only if they get affected by each other. जैसे कि हमने define किया था producer consumer problem. Producer and consumer are trying to access the buffer together at the same time. Then the synchronization requirement between producer and consumer is producer get affected by consumer when buffer is full and consumer gets affected by producer when buffer is empty. And also producer should wake up consumer and consumer should wake up producer whenever they are sleeping. And to ensure that there is never inconsistency, we treat or we consider buffer as critical section, so that अगर प्रोड्यूसर बफर को एक्सेस कर रहा है, बफर में है, तो कंज्यूमर शुड नॉट बी अलाउड टू एक्सेस द बफर। ये है कोऑपरेशन। So finally, we also looked into what are the necessary conditions to be present in IPC environment in order for problems of synchronization to arise. Those conditions are, we can say, like number one, there should be some critical resources, there should be some shared resources. So as such, in that regard, we say the program participating in IPC environment will be having two parts: critical code and non-critical code. Non-critical is that part of the program where we don't access any shared resource, and critical part is that program where we access shared resources. ठीक है? And then having critical section alone is not going to create a problem. Problem will arise when there is a race. Processes must be racing to access critical section. अगर कोई race ना हो, if there is no race to access critical section, there is never a problem. So race condition are the situations where processes are competing to access a shared resource, and eventually the result will depend on the order in which they finish their update. Only accessing is not going to create, there should be an update also. If there is no update involved, there is never a problem. Then having race condition alone is also not going to create a problem. What must exist is a preemptive environment. If there is no preemption, there is no problem. जो grassroots level पर problem creator है वो है premature preemption of the process. Premature in the sense that process before updating the value of the variable, it is getting preempted. So that may lead to basically problems. So eventuality कि जब ये three conditions exist हो IPC environment में, we may encounter these problems of synchronization. So this imposes us to solve the problem which is named as critical section problem. So फिर से एक बार यहाँ पर देख लीजिएगा. System we assume will have n processes. Each process will have critical section code. Processes may be changing common variables, updating file, updating table. So boys and girls, I would like to emphasize that maybe these are some of the critical section components. It may be common variables. It may be a table that you would like to update, or perhaps it may be writing to a file. It could be anything, any of these. These could be critical resources. When one process in critical section, no other should be allowed. Critical section problem. So therefore, that's what I'm saying. These are critical section problem. जो problem हमें solve करना है, so that only one process should be allowed to enter critical section. So that problem is named itself as critical section problem. So the solving the problem of critical section implies we need to develop a protocol to solve this issue of critical section. Each process, this is a basic ideology, boys and girls, this is a basic ideology. Every process that wants to enter critical section must ask permission to enter critical section in the entry section part of critical section, and then enter or access critical section, and after that in the exit section it should basically release the critical section. So that means the synchronization mechanism, which is the protocol basically to solve the critical section problem, will have entry section and exit section. Uska common element we have seen this structure. These are general structure of a process participating in IPC environment. So general structure of process. I may have entry, the process may have infinite loop, and then I have entry section, then critical, then exit, then remainder. Remainder is non-critical. Remainder is non-critical. So together we say that this entry and exit दोनों को मिलाकर आप बोलोगे synchronization mechanism. This is what is synchronization mechanism. ठीक है? So follow the terminology. इन दोनों को मिलाकर आप बोलोगे synchronization tool, synchronization mechanism, the protocol between the processes contending to access critical section. ये है the basic structure. तो जितने भी मैकेनिज्म्स डेवलप किए गए हैं और शायद आगे डेवलप होंगे, या आप खुद अगर नया मैकेनिज्म डेवलप करो, विल हैव टू फॉलो दिस स्ट्रक्चर. You need to develop the code of entry section, you need to develop the code of exit section, which will guarantee some requirements, right? So what are the requirements? हम आज स्टडी करेंगे. सुनिएगा बच्चों. The basic policy or the basic ideology is, जब भी कोई आपके पास कोई प्रॉब्लम हो, whenever you have any problem to solve, देखिएगा आपको पता होगा सॉफ्टवेयर इंजीनियरिंग टर्मिनोलॉजी में, every problem that needs to be solved will have its own requirements. हर एक प्रॉब्लम के अपने requirements होंगे. There is no problem without any requirements, whether it is computational problem, physics problem, mathematics problem, या general problem. Like I used to give some example. I want to solve the problem of preparation of timetable, class timetable. आपका engineering class का जो timetable है, that itself is a problem. If you want to develop a computer program for it, what are the requirements of it? उसके requirements है, who are the faculty, what are the subjects, what is the classroom, what are the class timings, ठीक है? And what are the timings of the classes which the faculty is already taking, so that there is no clash. ये सब आपको लेना होगा. These are what, not only the inputs but also the requirements. ये है कि no faculty should have a clash. शायद ये requirement हो सकता है कि the lab should be in the afternoon session. कोई faculty बोलेगा भैया मुझे first hour मत डालिएगा. These are requirement. So requirements are nothing but the conditions to be satisfied. उसी तरह और एक एग्जांपल लेता हूं. एक प्रॉब्लम है जिसका नाम है एन क्वींस प्रॉब्लम. आपने सुना होगा. ग्राफ बेस्ड एल्गोरिथम, ग्राफ बेस्ड प्रॉब्लम है और बैकट्रैकिंग का प्रॉब्लम है. एन क्वींस प्रॉब्लम, not graph based, it is a planar graph, you can say. The problem is we are given an n by n chessboard and n queens. We are required to place the queens on the chessboard in such a way that no two queens are attacking with each other. अब यहां पर condition for attacking is that no two queens should be on the same row, same column, same diagonal. ठीक है? These three conditions are called the requirements of n queens problem. हर एक प्रॉब्लम आप देखिएगा, डीबीएमएस का प्रॉब्लम हो, ऑपरेटिंग सिस्टम का प्रॉब्लम हो, या और कोई प्रॉब्लम, मेडिकल का प्रॉब्लम हो, या मैकेनिक्स केमिस्ट्री का प्रॉब्लम हो, मैकेनिक्स का प्रॉब्लम हो, जो भी सब्जेक्ट का प्रॉब्लम आप लीजिए, ईच एंड एवरी प्रॉब्लम विल हैव इट्स ओन रिक्वायरमेंट्स. उसी तरह जब हम ये प्रॉब्लम का नाम दे रहे हैं क्रिटिकल सेक्शन प्रॉब्लम, तो इसका भी अपना रिक्वायरमेंट्स होगा. What are the requirements of critical section problem to be satisfied by synchronization mechanism? Requirements of critical section problem. To be satisfied, या इसे आप कह सकते हो to be validated. By whom? By synchronization mechanism. जो आप सोल्यूशन डेवलप कर रहे हो, जो टूल डेवलप कर रहे हो, जो सॉफ्टवेयर चिप आप कहो डेवलप कर रहे हो, इट हैज टू सैटिस्फाई दिस रिक्वायरमेंट्स, इट हैज टू वैलिडेट दिस रिक्वायरमेंट्स. अगर ये जो रिक्वायरमेंट्स हम जो डिस्कस करने वाले हैं अगर वो सैटिस्फाई हो रहे हैं तो मतलब है योर सोल्यूशन इज करेक्ट, मतलब है कि यू विल नॉट हैव एनी प्रॉब्लम लाइक इनकंसिस्टेंसी, डेटा लॉस और डेडलॉक. So what are those requirements? Let us study one by one. Look at this. The first requirement is that, listen, mutual exclusion. So let me underline it. Mutual exclusion. What does principle of mutual exclusion say? The principle of mutual exclusion say that no two processes may be simultaneously present in their critical section. मतलब अगर कोई प्रोसेस क्रिटिकल सेक्शन एक्सेस कर रहा हो तो कोई दूसरा और प्रोसेस एक्सेस नहीं करना चाहिए, एंटर नहीं होना चाहिए. दैट इज म्यूचुअल एक्सक्लूजन. सी द डेफिनेशन. If process PI is executing in its critical section, then no other process can be executing in the critical section. दोनों एक साथ एक्सेस नहीं कर सकते एक के बाद एक. If one is present, other should not be allowed. If PI is present, PJ should not be allowed. PK should not be allowed. Nobody should be allowed. ये बहुत ज्यादा प्राइमरी रिक्वायरमेंट है. अगर म्यूचुअल एक्सक्लूजन वायोलेट होता है, इफ यू आर नॉट गारंटिंग म्यूचुअल एक्सक्लूजन, इट मींस यू आर लायबल टू सफर फ्रॉम इनकंसिस्टेंसी, मे बी डेटा लॉस. ये सबसे बड़ा प्राइमरी रिक्वायरमेंट है. अगर म्यूचुअल एक्सक्लूजन सेटिस्फाई नहीं हो रहा है तो देयर इज नो सेंस ऑफ अदर कंडीशंस. ये प्राइमरी है. यू कैन नॉट से दैट ठीक है सर मेरा सोल्यूशन तो म्यूचुअल एक्सक्लूजन सेटिस्फाई नहीं कर रहा है लेकिन अदर टू कंडीशंस आर डिसाइडेड, कैन आई एक्सेप्ट? नो सर, यू कैन नॉट एक्सेप्ट. ये प्राइमरी कंडीशन है. अदर आर डिजायरेबल, दे आर सेकेंडरी. सो म्यूचुअल एक्सक्लूजन एट एनी कॉस्ट मस्ट बी गारंटीड. सेकेंड कंडीशन, प्रोग्रेस. रीड इट. No process outside the critical section, no process who is disinterested, not interested in critical section, has got no right to block the progress of others, should not influence the other processes who are interested to participate in critical section. अगर मैं हूं, मैं इंटरेस्टेड नहीं हूं तो आई डोंट हैव एनी राइट टू ब्लॉक द प्रोग्रेस ऑफ अदर्स, टू इन्फ्लुएंस अदर्स, टू टेल अदर्स यू आल्सो डोंट गो और यू गो और यू डू नॉट गो. मुझे कोई इख्तियार नहीं है, मुझे कोई हक नहीं है to influence other processes progress. ये है progress condition. Read कीजिएगा definition. If no process is executing in its critical section, कोई process अगर critical section में नहीं है, and if there exist some processes, अगर कोई processes exist है that wish to enter critical section, समझ रहे हो बात? अगर critical section free हो और कुछ processes critical section में जाना चाह रहे हैं, ठीक है, then the selection of the process, मतलब जो सिलेक्ट होना है कौन जाएगा क्रिटिकल सेक्शन में, दैट राइट, कौन जाएगा दैट विल एंटर क्रिटिकल सेक्शन नेक्स्ट, कैन नॉट बी पोस्टपोन इंडेफिनिटली. मतलब ये इंडेफिनिट पोस्टपोन कब होगा? इफ समबडी इज ट्राइंग टू इन्फ्लुएंस, समबडी इज ट्राइंग टू से दैट you don't enter, you enter, or something like that, or trying to prevent others from entering critical section. So if critical section is free, nobody is there in critical section, and some processes want to enter, then the selection of the process who is going to enter critical section cannot be postponed indefinitely. मतलब कोई third process will try to influence it and try to block it. Yes or no? नहीं होना चाहिए. No, in इसका और एक वे में हम define कर सकते हैं, no process running outside the critical section should prevent the other processes from entering critical section. In a generic way also we say, in day-to-day life also we say, nobody has got the right to block progress of others. मैं at a lighter side used to tell as an example to my offline class students कि एक बच्चा है जो क्लास अटेंड करने अपने घर से स्टार्ट हुआ है, कॉलेज एंटर हुआ है. So while having entered into the college campus, so his desirability is to enter class, go to class. लेकिन कुछ और एक स्टूडेंट है वो कह रहा है कि today I am not interested. So if he is not interested, she is not interested, let him be not interested. लेकिन अगर वो दूसरा जो बच्चा है जाना चाह रहा है क्लास को, उसको ब्लॉक करेगा, भैया आज मैं इंटरेस्टेड नहीं हूं क्लास अटेंड करने में, तो ये है कि आप भी मत अटेंड कीजिएगा. दैट्स रॉन्ग. कोई अगर इंटरेस्टेड ना हो तो हाउ कैन ही और शी ब्लॉक द प्रोग्रेस ऑफ अदर्स? लेट देम गो इफ दे आर इंटरेस्टेड. व्हाई यू आर ब्लॉकिंग देम? So if you are blocking them, you are violating progress. ये है condition. No process running outside the critical section has got the right to block the progress of others. ठीक है? या इसका और एक भी वेरिएशन ये कह सकते हैं हम, अगर प्रोसेसेस इंटरेस्टेड है क्रिटिकल सेक्शन में, लेकिन इफ दे आर इंडेफिनेटली ब्लॉकिंग ईच अदर, इनफाइनाइटली ब्लॉकिंग ईच अदर, मतलब डेडलॉक का सिचुएशन है, देन आल्सो प्रोग्रेस इज वायलेटेड. क्यों? प्रोग्रेस का कंडीशन ये कहता है कि अगर क्रिटिकल सेक्शन फ्री हो और अगर कुछ प्रोसेसेस क्रिटिकल सेक्शन में जाना चाह रहे हैं, देन somebody should go eventually. अगर कोई भी नहीं जा पा रहे हैं, then also violation of progress. So deadlock implies violation of progress, boys and girls. याद रखने की बात है. So that is progress condition. Then finally, the third and so therefore this was my second condition, progress. So let me highlight. Then third I have bounded waiting. What is bounded waiting? In one way I can define, no process has to wait forever to access its critical section. No process has to wait forever to access its critical section. मतलब अगर एक process ने interest जाहिर किया है, has shown the interest to enter critical section, then it should not wait indefinitely or infinitely to enter critical section. It should enter the critical section in finite amount of time. In finite amount of time. तो अब यहां पर देखेंगे, ये जो definitions है, मैं जो बोर्ड पर जो definitions लाया हूं, these are the definitions from the textbook of Galvin. What it say for bounded wait? Have a look. A bound must exist on the number of times that other processes are allowed to enter their critical section after a process has made a request to enter its critical section and before that request is granted. थोड़ा सा लंबा statement है, लेकिन समझने की कोशिश करेंगे by taking a simple example. Imagine I have critical section and there are three processes trying to enter critical section. आप यहाँ पर उसे ऐसा समझ सकते हो. Let's say एक छोटा डायग्राम बनाएंगे यहाँ पर, this critical section, ठीक है, and this is entry section and this is exit section, and here are processes P1, P2, P3. You have designed your entry section which is guaranteeing mutual exclusion. Let us say it is guaranteeing or satisfying mutual exclusion. So P1 enters critical section through entry. जब P1 enter हो जाएगा critical section में, then P2 and P3 cannot enter. So let's say it is waiting. This arrow indicate they are waiting. They are waiting. Then P1 completing critical section will execute the exit part and again express the desire to enter critical section second time. Critical section तो free है. Other processes have already shown their interest. And while they are waiting, if you allow P1 again second time, what will happen? P2, P3 keeps on waiting. And if you are allowing it second time, you will allow without any reason for third time also, fourth time also. अगर आप उस तरीके से आप keep on allowing the process P1, then eventually what is going to happen? Eventually the processes who are waiting P2 and P3, who have also raised their request to enter critical section, they keep on waiting. And that will lead to starvation. The processes P2 and P3 keeps on waiting while P1 keeps on entering critical section. Starvation would happen to P2 and P3. Not desirable. We never want starvation to happen. We don't want starvation to happen. So, bounded wait. There must exist a bound on the number of times a process is allowed to enter critical section while others are waiting and their request is granted. Ideally, that bound is 1. जब तीनों प्रोसेसेस इंटरेस्टेड हो, एक प्रोसेस को एक ही बार जाना चाहिए क्रिटिकल सेक्शन में, अदर्स शुड बी गिवन लेटर चांस. अगर आप नहीं गारंटी कर रहे हो तो यू आर नॉट गारंटिंग फेयर शेयर. तो इवेंचुअली अगर मेरी टर्मिनोलॉजी में मैं कहूं तो ये होना चाहिए, व्हेन 3 आर इंटरेस्टेड, you should follow a concept like round robin. You have to follow a concept like round robin. First P1, then P2, then P3, then again P1, like that. Fair share. Dissatisfying fair share, eventuality is starvation. So bounded waiting is not guaranteed, starvation will happen. Progress is not guaranteed, indirectly starvation would happen. So starvation is the end result that may happen due to lack of synchronization between processes, violating the bounded weight condition and violating progress condition. तो ये हमें understand करना है with regard to the requirements. In short, I can say that no process has to wait forever to access its critical section, bounded weight. Tenenbaum textbook के definitions of requirements काफी easy है than in comparison to Galvin. I would request that's why to follow the Tenenbaum textbook for synchronization basics. Basics के लिए Tenenbaum textbook अच्छा है for synchronization chapter. तो ये है bounded weight. हाँ, यहाँ पर बच्चों को एक confusion होता है. See, suppose for example, under what circumstances can a process like P1 be allowed to enter critical section anytime, any number of times? फिर से कह रहा हूं, under what circumstances, कौन से circumstances में आप allow करोगे एक process P1 को multiple times to enter critical section? That will happen only if and only if the other processes are not interested. अगर P2 and P3 are not interested and in P1 want to enter critical section any number of times, you must allow. लेकिन if P2 and P3 are interested, आप allow नहीं कर सकते P1 को. स्ट्रेट फॉरवर्ड कॉन्सेप्ट है, कॉमन सेंस है. You cannot allow P1 any number of times. अगर आप allow करोगे तो P2 and P3 keeps on waiting. Starvation would happen. We don't want. We want a fair share when all processes or subset of processes are interested to access critical section. तो बच्चों ये है 3 requirements. तो जब भी कोई synchronization tool या synchronization mechanism develop करोगे आप, we have to guarantee that, we have to ensure that they satisfy these 3 requirements. So these 3 requirements, if they are validated, satisfied, certified, then we say that our synchronization mechanism as a security guard, as a security chip, as a software chip, as a protocol is a correct mechanism which will make sure that will not have any inconsistency, will not have any deadlock, will not have any data loss. ये है मतलब. Finally, there are subsidiary conditions like you see. Assume that each process executes at a non-zero speed. Means processes will be proceeding. No assumption concerning relative speed of the end processes. एक process fast है, एक process slow है, ऐसा assumption नहीं है. So boys and girls, these are called the requirements for solution to critical section problem. ठीक है? तो इससे पहले मैं once we start the synchronization mechanisms, मैं आपको एक टैक्सोनॉमी बताना चाहूंगा, क्लासिफिकेशन बताना चाहूंगा with regard to synchronization tools or synchronization mechanisms so that you have some clarity of understanding. How are synchronization mechanisms classified and categorized? तो आपने कौन से mechanisms पढ़ना है with regard to gate preparation? What are the various synchronization mechanisms that you need to study? For dealing with the problems of critical section? हाँ, देखिएगा, synchronization mechanisms are classified into two types. One is called busy waiting. And the other is called non-busy waiting. या आप कहो blocking. एक बेसिक एग्जांपल दूंगा टू मेक यू अंडरस्टैंड व्हाट इज द मीनिंग ऑफ बिजी वेटिंग. बिजी वेटिंग का मतलब यह है कि प्रोसेस विल हैव सॉर्ट ऑफ लूप. एक एग्जांपल दे रहा हूं. व्हाइल you will have some condition and if condition is true, you do nothing, null statement, and you keep on looping. ये है ideology of busy waiting. Any process trying to enter critical section will test the condition in the while loop. If the condition is true, that means critical section is free. It does nothing and keep on looping. That is called busy executing the loop condition and waiting to enter critical section, busy waiting. So many of the mechanisms are categorized as busy waiting, and sometimes we also call busy waiting as spin lock. The process is spinning like a top, लट्टू की तरह फिर रहा है, spin and locked to enter critical section. So that is spin lock or busy waiting. And generally busy waiting conditions or busy waiting loops or busy waiting mechanisms are implemented using loops. It may be a while loop, it can be a repeat while loop, it can be repeat until, do while, for loop भी हो सकता है, loop से होगा. Invariably कहने का मतलब ये है कि processes will be testing the condition of critical section multiple times before entering critical section. या आप कह सकते हो कि दिस इज जस्ट लाइक, अगर आप कंप्यूटर ऑर्गेनाइजेशन की टर्मिनोलॉजी की बात करोगे, आई वुड ट्रीट दिस कॉन्सेप्ट ऑफ बिजी वेटिंग इज लाइक पोलिंग. अगर आपको पता हो आईओ मैकेनिज्म्स, डेटा ट्रांसफर मोड्स, उसमें एक मैकेनिज्म है कॉल्ड पोलिंग. Polling means the process will be continuously polling the device to check whether it is ready for input output transfer or not. So polling is exactly the concept of busy waiting. Busy waiting का problem ये होगा कि it may lead to wastage of CPU cycles, it may lead to wastage of CPU time. Busy waiting का drawback है वो. So drawback of busy waiting may lead to wastage of CPU time. To counter that wastage of CPU time, to avoid that wastage of CPU time, you go for non-busy waiting, blocking. This desirable solution. It will not lead to wastage of time. यहाँ पर the condition of the critical section in the entry section will be tested in like if then else. If condition, you will have something and then you will have something, then else something, if then else. So all busy waiting, non-busy waiting mechanisms are generally implemented using if then else condition. Test of condition is done only once. अगर critical section used में है तो block हो जाएगा process. It will leave the CPU immediately and get blocked. So that's why it is trying to optimize CPU time. It will lead to blocking of the process, finding that critical section is in use. अगर critical section free हो तो critical section में जाएगा. ये है solution of this. Then what are the mechanisms that you need to study from the perspective of gate for busy waiting based solutions? इसमें सबसे पहले आएगा lock variable. A category of solutions है which are based on lock. So I name from my side as lock variable. Second approach towards solving is called strict alternation. Based on the gate type of questions, I am naming these mechanisms. The third that you need to study is Peterson protocol. Fourth one is Decker's algorithm. Decker's algorithm. Next, you may have, for example, bakery algorithm. And these are categorized in the busy waiting mode. In the busy waiting mode, these are categorized as, or sub-categorized, I would say. These are sub-categorized as software solutions. Software solutions का मतलब ये है, they are implementable purely at user mode. ये user mode में work करेंगे. They don't require any operating system support. They don't require any special hardware support. And contrary to that, I also have some busy waiting solutions which are hardware based. That is called synchronization hardware. You will have mechanisms like TSL, swap, and CAS, compare and swap. So these are mechanisms in the hardware category. The hardware category के mechanisms है. So this is hardware category. We say synchronization hardware. Hardware का मतलब ये नहीं है कि you have a device which is there in the market, you go and purchase and use. No, hardware का मतलब ये है कि processor will support some special hardware instructions, architecture specific instructions which are used to solve the problem of critical section. ये है hardware. And coming to non-busy waiting class, we have mechanisms like sleep and wake up. Sleep and wake up primitive, starting as a foundation concept. And then the most important one in this category is semaphore. And the last one is monitors. Monitors. These are essentially, you can say, subcategorized as OS based. Monitor is strictly not OS based, but still we are categorized in the OS based because it makes use of operating system primitive like binary semaphore to guarantee its requirements. यहाँ पर मतलब OS based का ये है कि they are supported by operating system kernel. That's why they are said OS based. So my dear students, what I wanted to tell you, in non-busy waiting category, we can also have sub mechanisms like mutex locks. And sometime atomic variables like this. These are all mechanisms. So from gate examination perspective, you are compulsorily required to prepare for all these mechanisms. And I will try to touch upon all these, giving you details in this Naya Aghaaz series. Okay? All these are various synchronization tools or synchronization mechanisms, security guards, software chip, protecting critical section. Further, I would like to say that these mechanisms can also be categorized. These mechanisms can also be categorized as either two-process solution or multi-process solution. Two-process or multi-process. Two-process matlab it can work with only two processes. It cannot work with more than two. Multi-process generally means more than two. More than two. So boys and girls, this is the entire taxonomy classification of mechanism categorized as busy waiting, non-busy waiting, software, hardware and OS based. चलिए start करते हैं with the first mechanism which is called lock variable. I will tell you the ideology behind it. So the first mechanism in discussion is lock variable. The basic ideology of lock is primarily central for many other mechanisms including hardware. I will try to explain to you this approach by means of a diagram. Imagine this critical section and let's say this is entry and this is exit. Okay? This is entry, let us write, and this is exit. So here I have processes P1, P2, P3 and so on. So as I said already, this is software based and this is my user process, and let me just add on here that this is multi-process solution. Multi-process. It can work with more than two processes, P1, P2, P3. That's why I have taken P1, P2, P3. So this is my critical section. And multiple processes are trying to enter. What happens is, यहाँ पर entry section में we will have a variable, shared global variable by name lock. This variable by name lock. It's a Boolean variable, or you can say binary variable, which can take only two values, 0, 1, true, false. 0 is false, 1 is true. So lock, boys and girls, can take two values, either 0 or 1. What is the implication of lock being 0 and lock being 1? Let us write here. अगर लॉक की वैल्यू 0 हो तो मतलब यह है कि क्रिटिकल सेक्शन इज फ्री, नोबडी इज देयर इन क्रिटिकल सेक्शन. और अगर लॉक की वैल्यू 1 हो तो मतलब क्रिटिकल सेक्शन इन यूज. ये मतलब है. अगर लॉक की वैल्यू 0 हो तो क्रिटिकल सेक्शन फ्री है, कोई भी प्रोसेस जा सकता है. वरना अगर लॉक की वैल्यू 1 है तो दैट मींस क्रिटिकल सेक्शन इज इन यूज एंड द प्रोसेस विल हैव टू वेट. व्हाट काइंड ऑफ वेट? बिजी वेट. So we will define the protocol as follows. Any process desiring to enter critical section will have to check the value of lock. If the value of lock is 0, that means it can enter critical section. लेकिन critical section में enter होने से पहले it has to make sure that it should lock critical section by making lock to 1. वरना अगर वो lock को set नहीं करेगा, lock की value 1 नहीं बनाएगा, तो ये हो सकता है कि अदर प्रोसेस में also simultaneously enter along with it. So to avoid that, we have to make the value of lock to 1 and then enter critical section. Agar value of lock is already 1, the process will have to busy wait. And finally, when the process complete the critical section in finite amount of time, then the process should come out from critical section and make the value of lock to 0. That's it. This is the protocol. लेकिन यहां पर आपको लिखने कोड लिखने से पहले आपको बताता चलूं, देयर आर सम रियलिस्टिक assumptions के process can get preempted while executing entry section code. Process can get preempted while executing critical section code क्योंकि user mode है. And process can get preempted after completing critical section but before executing exit section. And we assume that critical section is flawless. कोई किस्म का प्रॉब्लम नहीं होगा क्रिटिकल सेक्शन. आप ये नहीं कह सकते क्या होगा सर if a process fails in critical section. There are no assumptions. There are no assumptions like that. We assume critical section is a black box. We assume that the process will enter critical section, spend finite time in critical section and come out. कितना टाइम स्पेंड करेगा? We don't bother. Finite amount of time. एक फाइनाइट टाइम में प्रोसेस क्रिटिकल सेक्शन से कंपलसरी बाहर आएगा ही आएगा. एंड फाइनली एक और बात कहता चलूं कि ए प्रोसेस इज सेट टू लीव द क्रिटिकल सेक्शन. हम कब बोलेंगे प्रोसेस हैज लेफ्ट द क्रिटिकल सेक्शन? जब बोलेंगे कि व्हेन इट हैज कंप्लीटेड एग्जिट सेक्शन. जब तक एग्जिट सेक्शन कंप्लीट ना हुआ हो ऑफ प्रोसेस, हम ये नहीं कह सकते कि प्रोसेस हैज लेफ्ट क्रिटिकल सेक्शन. ये बहुत ज्यादा इंपॉर्टेंट पॉइंट्स है बच्चों, टू कीप इन माइंड. प्रोसेस इज सेट टू लीव द क्रिटिकल सेक्शन व्हेन इट हैज कंप्लीटेड एग्जिट सेक्शन. तभी कोई दूसरा प्रोसेस आ सकता है. ठीक है. A process while executing critical section can get preempted from CPU and put back into the ready queue. Then also we say critical section is in use even though it is not running right now on CPU. Critical section is under its control. These are the points which you have to keep in mind. So based on this, we can project, we can make an attempt to write the code of lock variable. कैसे दिखेगा code? I will write down the code here. Please follow me carefully. I will define a global variable by name lock. The initial value of lock should be 0 naturally because initial value of lock indicate the status of critical section. So naturally critical section शुरू में free रहेगा, तो lock की value 0 होना जरूरी है. Lock must be 0. ठीक है? Then what? Just a second. Let me have some water. So if lock is 1, nobody can enter critical section. That is absolutely wrong. Lock must be 0. अब इसके बाद we will have to write the code of entry section and exit section, or we can write the code in the form of the whole process as such. So I will write the whole process. The I is process ID P1, P2, P3, P4, something like that. So any process desiring to enter critical section will have to execute this code, right? So I would say while of 1. While of 1. Initially, we may assume process may have non-critical section. Non-critical section is also called remainder section. You can put non-critical section anywhere, here in the beginning or at the end, in the middle, wherever you want. अब now the process may desire to enter critical section. तो क्या करेंगे हम? entry section code define करना है. This is busy waiting solution. I will have to take a while loop. So while loop का condition क्या होगा? What is the condition for the process to busy wait? While lock is not equal to 0. Not equal to 0 का मतलब 1 है. Lock is 1. अगर lock 1 हो तो process has to wait, busy wait. So I tell do nothing, null statement, and process keeps on busy waiting. ये है busy waiting condition. If lock is 1, 1 is not equal to 0, true, I keep on busy waiting here. अगर lock की value 0 हो, the condition fails, we come out from the loop. तब हमें क्या करना होगा? तब हमें यहां पर lock की value 1 बनाना होगा. सुनिएगा, अगर for example, if lock is not equal to 0, it waits. If lock is equal to 0, it comes out and set lock equal to 1. Observe कीजिएगा कि lock equal to 1 is outside the loop. Outside the loop. ठीक है? It is outside the loop. Loop is terminating therein. So this is my entry section. So boys and girls, let me emphasize. ये है आपका entry section. Entry section की logic है. ठीक है ना? अब इसके बाद देखिएगा, आई विल हैव क्रिटिकल सेक्शन कोड. यहां पर आप क्रिटिकल सेक्शन का कोड है. ठीक है, ये क्रिटिकल सेक्शन का कोड है. वॉट एवर यू वांट टू एग्जीक्यूट. क्रिटिकल सेक्शन में क्या है, कितने इंस्ट्रक्शन है, क्या है, वी डोंट बॉदर. वी ओनली सेड, एज आई सेड अर्लियर, प्रोसेस विल स्पेंड फाइनाइट टाइम इन क्रिटिकल सेक्शन एंड विल कम आउट. और एग्जिट सेक्शन में जब आएगा प्रोसेस, क्या करेंगे हम एग्जिट सेक्शन में? As I told earlier, when a process comes out from exit section, what will it do? It will simply make the value of lock to 0. And that's it. The entry, the critical section, and this is my exit section. This is exit section. ठीक है? End of the program. ये है लॉक वेरिएबल का मैकेनिज्म. So boys and girls, you will be given the code like this and then you will be asked whether this solution is correct or incorrect. Okay? अगर आप देखो तो basic ideology is seemingly looking like correct. लेकिन you are not supposed to just read the code through your eyes and tell that it is correct. आपको लगेगा ये करेक्ट है. टू प्रूव और वैलिडेट आपको एक डाइसेक्टिंग एनालिसिस करना पड़ेगा विथ योर ब्रेन, नॉट विथ योर आइज. मैं फिर से कह रहा हूं, अगर आप एक बार रीड करोगे तो आपको परफेक्ट लगेगा सोल्यूशन, लेकिन परफेक्शन वो नहीं है. परफेक्शन ये है कि आपने एनालाइज करना होगा, डाइसेक्टिंग एनालिसिस, एंड दैट इज व्हाट इज द ब्यूटी ऑफ सिंक्रोनाइजेशन मैकेनिज्म और सिंक्रोनाइजेशन टॉपिक. यहीं पर एनालिटिकल सेटअप में, एनालिटिकल फ्रेमवर्क में स्टूडेंट्स विल मेक मिस्टेक एंड दे फील दैट सिंक्रोनाइजेशन इज हार्ड. You have to carry out analysis in a preemptive environment. You have to carry out analysis in a preemptive environment. When you assume preemption is happening, अगर आपकी टाइप ऑफ शेड्यूलिंग प्रीएम्प्टिव हो तब प्रॉब्लम आएगा. अगर आपकी शेड्यूलिंग नॉन प्रीएम्प्टिव हो तो कोई प्रॉब्लम नहीं होगा. जैसे ही आप नेसेसरी कंडीशन को नेगेट करेंगे प्रॉब्लम नहीं आएगा, राइट? तो नॉन प्रीएम्प्टिव शेड्यूलिंग से प्रॉब्लम नहीं होगा, प्रीएम्प्टिव शेड्यूलिंग, प्रीएम्प्टिव एनवायरनमेंट से प्रॉब्लम होगा. तो my question is, that's how it will be asked in your exam. Does this solution of lock variable which has been given here, does it guarantee mutual exclusion or not? Does it guarantee progress or not? Does it guarantee bounded waiting or not? तो सबसे पहले हमें स्टार्ट करना होगा म्यूचुअल एक्सक्लूशन. इफ यू जस्ट रीड द कोड विदाउट एनी प्रीएम्प्शन, इट विल गारंटी म्यूचुअल एक्सक्लूजन, बिल्कुल गारंटी करेगा. लेकिन अगर प्रीएम्प्टिव एनवायरनमेंट हो, जब मतलब प्रीएम्प्शन कहीं भी हो सकता है, कभी भी हो सकता है. So under preemptive environment, the process can get preempted in the entry section code. Process can get preempted while executing this while loop. या process after completing the while loop get preempted before setting lock to 1. अगर ये आप consider करो तो क्या होगा? तो if you carry out a dissecting analysis like that, a scenario can be taken like this. Please follow me carefully. I'm telling orally. Suppose imagine lock is 0. And if some process is trying to enter, P1 trying to enter, P1 has read the value of lock, has compared the value of lock, found the value of lock to be 0. So this condition fails. ठीक है ना? P1 is telling that the condition fails. Lock is 0 and is not equal to 0, false, fails. मतलब हमें lock equal to 1 execute करना है. So P1 got preempted before setting lock to 1. मतलब it got preempted from CPU and put back to ready queue. और नेक्स्ट टाइम इन फ्यूचर जब भी P1 रेडी क्यू से रनिंग स्टेट में आएगा, वेयर विल इट कंटिन्यू इट्स एग्जीक्यूशन फ्रॉम? इट विल कंटिन्यू फ्रॉम लॉक टू 1 एंड एंटर क्रिटिकल सेक्शन. मतलब कहने का मतलब ये है कि P1 has seen the value of lock as 0, was about to go to critical section. Just before going to critical section, it got preempted. That was not the fault of process. That was the fault of operating system, you can say, because of preemptive scheduling. It preempted. आप यहां फिर पूछ सकते हो सर वो क्यों preempt हुआ? बेटा, cause of preemption could be anything. आपने पढ़ा है already. Process in user mode can get preempted for any reason. हो सकता है टाइम क्वांटम एक्सपायर हो चुका हो सकता है कोई और प्रायोरिटी इंटरप्ट आया हो, तो ऑपरेटिंग सिस्टम को सर्विस करना है इंटरप्ट, इट गॉट प्रीएम्प्टेड. Cause of preemption could be anything. That is a universal golden assumption of operating system that runs in preemptive mode in user mode. So P1 before setting lock to 1 it got preempted. मतलब अगर मैं virtually कहूं, logically कहूं, तो process P1 has gained the access of critical section. Logically P1 is in critical section, logically, not physically but logically under control में है उसके. अब देखना यह है कि कोई और प्रोसेस P2, P3 if they want, will they be allowed or not? Should P2 or P3 other processes should be allowed? No sir, they should not be allowed. But will they be allowed? चेक करना होगा, हमें चेक करेंगे. I start with P2. P2 also starts. While lock is 0 still because lock was not set to 1 by P1, lock is 0. P2 starts. While lock is not equal to 0, yes, it is not equal to 0. It will make lock to 1, let us say. It will make lock to 1. Lock has become 1 by whom? By P2. And then P2 enter critical section. Physically P2 has entered critical section. And that itself is wrong now. आपको समझाने के लिए कहूंगा. Now after executing some part of critical section, who? P2. P2 कुछ part of critical section execute करने के बाद, it left the CPU, it got preempted from CPU. So while holding critical section, while executing some part of critical section, P2 got preempted from CPU. And is there in the ready queue. Now P1 gains the control. हमने क्या कहा था पिछले साइकिल में P1 के? हमने कहा था कि next time whenever P1 runs, it is going to execute lock to 1 and enter critical section. हमने वही कहा था, P1 is logically in critical section, so it will make lock to 1 and enter critical section. The moment both processes are in critical section, it is a proof of the violation of mutual exclusion. So therefore we say in summary that lock variable जो description है यहाँ पर, it gives an impression as if it guarantee mutual exclusion. It gives you an impression. It gives you an impression that it guarantee mutual exclusion, but in fact when you carry out a preemptive analysis, it does not guarantee mutual exclusion. It does not guarantee. It fails to guarantee mutual exclusion. So सबसे पहले हमें यहाँ लिखना होगा lock variable fails to guarantee mutual exclusion. आप कह सकते हो सर does it guarantee mutual exclusion sometimes? हाँ बेटा बिल्कुल, sometimes it guarantee. लेकिन क्या are we looking for sometimes? No, we are not looking for sometimes. We are looking for guaranteeing mutual exclusion every time, whether preemption takes place or not, whether I start with this process or that process. It should guarantee mutual exclusion always. That is our requirement. And we are proving in one case that it is failing to guarantee mutual exclusion. तो बेटा अगर आप सिर्फ एक केस एक सिनेरियो में अगर डेमोन्स्ट्रेट कर पा रहे हो कि it is the solution is not meeting mutual exclusion, that is enough to say that solution is incorrect. When it is failing to guarantee mutual exclusion means I may get problem of inconsistency, I may get problem of deadlock, data loss or anything. So at any cost. और एक पॉइंट ये कह रहा हूं, म्यूचुअल एक्सक्लूजन का वायोलेशन अगर आपको प्रूफ करना है तो आपको जिस तरह मैंने यहां पर बताया उस तरह बताना होगा कि हाउ टू प्रोसेसेस आर इन क्रिटिकल सेक्शन. ये आप प्रूफ कर दो that at any time there are two processes at least in the critical section, that is enough to prove failure of mutual exclusion. Our next condition we have to see for progress. What do you say about progress? Progress हमने क्या कहा था? If a process, somebody is not interested in critical section, Can it prevent the other process from, or prevent or block the other process from entering critical section? क्या ऐसा हो सकता है? देखेंगे solution. Okay, you have to imagine like this. Some process is busy in non-critical section. Can it prevent other process from updating lock or manipulating lock? No. Nobody is running outside the critical section would influence the process from entering critical section. So therefore, always guarantee progress. Always guarantee progress. Third, we have to check bounded weight. Does it guarantee bounded weight? What is bounded weight? क्या ये हमें प्रूफ करके चेक करना होगा, हमें चेक करना होगा कि can we prove that a process can enter critical section multiple times while other process is waiting to enter critical section. So we'll take a simple scenario wherein I would say that maybe the P2 and P3 are waiting in the while loop. They are busy waiting in the while loop here because P1 is in critical section. So boys and girls, here you have to imagine a situation. P1 has entered critical section. P1 has entered critical section and P2 and P3 gave their try. They found the critical section is in use. So they are in the busy waiting loop and they are waiting in the ready queue. They are in the ready queue. Now the control on CPU is with P1 who is in critical section. Now imagine. So once again I am reiterating. First time P1 entered critical section. It got preempted from CPU. P2 try busy wait. P3 try busy wait. They left the CPU and they are there in the ready queue. So invariably we are saying critical section is in use, other processes are busy waiting. Now imagine, P1 gains the control of CPU, it runs on CPU and then it completes critical section. After completing critical section, so let's say here, it complete critical section. It complete critical section. And then make lock to 0. Make lock to 0. And in the loop, without getting preempted, in the loop it goes back and express the desire to enter critical section again second time. Who? P1. P1 ने critical section से बाहर आने के बाद लॉक की वैल्यू 0 कर दी और उसके बाद without losing CPU, without getting preempted from CPU, it expressed the desire to enter critical section again second time. Can it be allowed or not? ये हमें चेक करना है. अगर आप देखोगे, गौर करोगे, it will check value of lock as 0, immediately find it to be false and make lock to 1 and enter critical section again. हाँ हो सकता है ऐसा. Then what will happen? P2 and P3 keeps on waiting and P1 keeps on entering critical section again and again, again and again, again and again. So that is violation of progress. Bounded wait. These two processes are keeping on waiting. Starvation हो जाएगा. So dissatisfaction of bounded wait will lead to starvation. और starvation हो रहा है. So therefore, lock variable fails bounded wait, fails to satisfy bounded wait. ये है analysis of the first mechanism, which is called lock variable. So lock variable does not guarantee mutual exclusion, guarantee progress and fails to guarantee bounded wait. तो मतलब ये है कि it is not a correct solution, लेकिन seemingly the ideology is correct. जो ideology है, the basic core logic है वो correct है, लेकिन the problem is happening due to preemption. अगर हम somehow that preemption को control करेंगे, then our problem will be solved. So therefore outrightly हम lock variable को reject नहीं करेंगे, तो उसकी core logic जो core idea है, basic philosophy जो है वो that is correct. तो उसको हम थोड़ा फाइन ट्यून अगर कर लेंगे, तब प्रीएम्पशन को कंट्रोल कर लेंगे somehow, then we can overcome the problem. ठीक है, तो वो कंट्रोल किया जाएगा हार्डवेयर सिंक्रोनाइजेशन में, जहां पर बात होगी TSL एंड स्वैप एंड कंपेयर एंड स्वैप इंस्ट्रक्शंस की. ठीक है, वो बाद में देखेंगे. उससे पहले एक सेकंड सॉफ्टवेयर सोल्यूशन है जिसका हम डिस्कशन कर लेते हैं, जिसका नाम है the name of this is strict alternation. strict alternation. So as I mentioned earlier, this is also a software solution. ये भी एक software solution है, and this is limited to work with only two process. So let me write here. These are two process solution. Busy waiting है, but two process solution. It can work with only two processes. You may name the process as P0 and P1, or in a generic way you can name it as Pi and Pj. I is one process, J is other process. मतलब if I is 0, J will be 1. If I is 1, J will be 0. ये मतलब ठीक है. That's the point. So this is also, we can say, the solution which is based on what is called turn variable. Turn variable based mechanism. Turn variable based mechanism. मतलब I will give you the ideology of it, either through a schematic or through a diagram. Imagine this critical section, and this is entry and this is exit. So here I have a variable. I have to take some variable by name turn. This variable turn is going to indicate which process turn is it to enter critical section. टर्न की वेरिएबल वैल्यू हमें बताएगी कि कौन से वेरिएबल का टर्न है टू एंटर क्रिटिकल सेक्शन. Turn will always tell which process turn is it to enter critical section. Is it I or J? Is it 0 or 1? Like that. So for example, if I say if the value of turn is I, then it is process Pi's turn to enter critical section. On the other hand, if the value of turn is J, then it is process Pj's turn to enter critical section. So मतलब ये है, अगर पूरा प्रोटोकॉल हम डिस्क्राइब करने की कोशिश करेंगे, any process desiring to enter critical section, whether it is Pi or Pj, any process which is desiring to enter critical section will have to check the value of turn. If turn is I, then it is process Pi's turn to enter critical section. If turn is J, it is process Pj's turn to enter critical section. मतलब टर्न की वैल्यू J है और Pi एंटर होना चाह रहा है तो वो एंटर नहीं हो सकता, इट हैज टू बिजी वेट. वाइस वर्सा, टर्न की वैल्यू J है, I cannot enter. तो मतलब एनी प्रोसेस desiring to enter critical section will have to inspect the value of turn, check the value of turn. If it is its turn, enter. If it is not its turn, busy wait. और critical section से बाहर आने के बाद, to allow the other process waiting to enter critical section, it has to set the value of turn to ID of other process. If turn was I will enter. Then turn Pi will come out and make turn to J so that J can enter. ये है ideology. So therefore, in this regard, we make a claim saying that strictly on alternate basis, ऐसे लिखेंगे हम, strictly on alternate basis, processes takes turn to enter critical section. Strictly on alternate basis, processes takes turn to enter or access critical section. First Pi, then Pj, then Pi, then Pj, then Pi, then Pj, like that. So based on this, I will project the code, बच्चों. I will write down the code here. So please follow. So let's write. Check. So I will first define the global variable by name turn. Turn की value कुछ भी हो सकती है initially. So I would say randomly you can initialize as either I or J. Randomly. Either I or J. and here I will project the code of the process. Void process I. I may be 0 or I may be 1. If I is the current process, J is the other process, तो हमें एक वेरिएबल डिफाइन करना पड़ेगा जिसका नाम है J, and we will say J is equal to not of I. Not operator will give me the ID of other process of I. मतलब if I is 0, not of I become 1. If I is 1, not of 1 becomes 0. J will become 0. So I is one process, J is other process. तो यहां पर लाइफ साइकिल अगेन विल बी इनफाइनाइट लूप. So I would say while of 1. Again the process may have non-critical section. And then the process will have entry section code. So the entry section busy waiting है तो फिर से हमें while loop आएगा यहाँ पर. So I will say what? Now the question is, under what circumstances, when should process I, running process is I, when should process I busy wait? Process I should busy wait when it is not its turn. मतलब turn की value I ना हो तो उसे busy wait करना है. तो therefore I will simply write turn is not equal to I, busy wait. लेकिन अगर टर्न इक्वल टू आई, दिस कंडीशन फेल्स. अगर टर्न की वैल्यू आई हो तो ये कंडीशन फेल होगा, हम बाहर आएंगे एंड द प्रोसेस कैन गो टू क्रिटिकल सेक्शन. प्रोसेस कैन गो टू क्रिटिकल सेक्शन. और जब प्रोसेस क्रिटिकल सेक्शन से बाहर आएगा तो क्या करेगा? शुड मेक द वैल्यू ऑफ टर्न टू द आईडी ऑफ अदर प्रोसेस. टर्न विल बिकम जे. दैट्स ऑल. दिस द कॉन्सेप्ट, नो रॉकेट साइंस. कूल एंड कंफर्टेबल सॉल्यूशन. तो बेटा ये है एंट्री सेक्शन. थोड़ा ऊपर से ड्रॉ कर लें. एंड दिस इज एग्जिट. So therefore this is entry, exit. This is a mechanism. फिर वही कि we have to validate whether does this guarantee all the three requirements or not. तो सबसे पहले हमें टेस्ट करना होगा mutual exclusion. Come on, I'll give you time. Think it over and just let me know whether it guarantee mutual exclusion or not. Evaluate कीजिएगा. Check for a while. Can it happen? अगर म्यूचुअल एक्सक्लूजन आपको डिनाई करना है, वायोलेट करना है, या अगर आप कह रहे हो कि म्यूचुअल एक्सक्लूजन इज फेलिंग हियर, तो आपने प्रूफ करना है कि बोथ प्रोसेसेस कैन बी इन क्रिटिकल सेक्शन. क्या ऐसा हो सकता है? At any case, whenever preemption is also there, is it possible that both the processes I and J can be in the critical section together at the same time? क्या ऐसा हो सकता है? Is a question. सोच समझ के बताइए. Here, if you observe, turn will take one value, either I or J. Let's say turn is I. Then in the while loop, both the processes will read the same value of turn. और उसके बाद टर्न की वैल्यू हम इमीडिएटली अपडेट नहीं कर रहे हैं इन द while loop या आउटसाइड द while loop, unlike clock variable. So it implies that both the processes will read the same value of turn, and for one process condition of while loop will be true and for other process condition of while loop will be false. तो जो प्रोसेस के लिए while loop condition false हो रहा है, मतलब यह है कि वो उसका टर्न है, so it will go to critical section and the other process will wait. So this implies that mutual exclusion is always guaranteed with strict alternation. It always guaranteed. So therefore always guaranteed, I will put a tick mark. Always. Second हमें टेस्ट करना होगा प्रोग्रेस. Progress क्या कहता है? Again I am trying to emphasize. Progress conditions say that if some process is disinterested, if somebody is not interested, can it prevent the other interested process from entering critical section? क्या ऐसा हो सकता है? या फिर ये भी प्रूफ कर सकते हो आप, क्या यहां पर कोई डेडलॉक की पॉसिबिलिटी हो रही है, क्या डेडलॉक हो सकता है, अगर डेडलॉक भी हो तो प्रोग्रेस वायलेशन है। ठीक है, तो यहां पर चेक कर लेंगे। इमेजिन वी कैन टेक अ सिंपल सिनेरियो, इमेजिन द वैल्यू ऑफ टर्न इज समथिंग लाइक दिस, टर्न इज आई, इसका मतलब है पी आई कैन एंटर क्रिटिकल सेक्शन, पीजे कैन नॉट। लेकिन व्हाट इज द स्टेट ऑफ पी आई? लेट अस इमेजिन PI is busy in its non-critical section. Let me write down here. Let me write down. PI is busy in its non-critical section. मतलब PI is not interested in critical section. And PJ, the other process, PJ is interested. तो अब क्या होगा यहां पर देखिएगा, PJ will come and start executing the while loop. Turn is J. J is not equal to I, yes, so it keeps on busy waiting. Because turn is not J, so J will keep on busy waiting, it cannot enter critical section. And who is liable to enter, who is supposed to enter? I. And what is the status of I? I say that I am not interested. What is critical section? Is it free or in use? It is free, sir. So PJ, should it enter? Yes, it should enter, because critical section is free. But the question is, can it enter? No, sir, it cannot enter. Why? Who is blocking? PI is blocking. PI is telling PJ that unless I enter critical section and come out, you cannot enter. PJ, you cannot enter. And right now, I am not interested in critical section. So, you break your head in the while loop. It is telling, PI is telling PJ, you break your head in the while loop. You do whatever you want. ठीक है? But I am not interested right now. और फिर ये कह रहा है, I am not interested. और जब तक मैं क्रिटिकल सेक्शन में जाकर ना बाहर आऊं, तब तक तुम नहीं एंटर कर सकते, यू कीप ऑन वेटिंग। ये गलत बात है। So PI is blocking PJ from entering critical section unnecessarily. ये है violation of progress. ये है violation of progress. So therefore, strict alternation does not guarantee satisfy progress. ठीक है। अब थर्ड कंडीशन है बाउंडेड वेट। सी ऑन बोर्ड, bounded weight. Bounded weight means we have to check, like lock variable, can a process after coming out from critical section, can it again enter again and again and again? क्या ऐसा हो सकता है? Let's imagine turn is I and PI want to enter critical section, so it will enter. उसके बाद जब बाहर आएगा, it will make turn to J. And after making turn to J, if PI wants to enter again, it will go back and it will start again. It will read here turn is J is not equal to I, true, it will wait. It is not allowed. मतलब एक प्रोसेस क्रिटिकल सेक्शन में एंटर होने के बाद फिर से वो दूसरी बार नहीं जा सकता until the other process enter critical section. So therefore this will guarantee bounded weight. This will guarantee bounded weight unlike lock variable. तो बच्चों, स्ट्रिक्ट ऑल्टरनेशन गारंटी म्यूचुअल एक्सक्लूजन, डज नॉट गारंटी प्रोग्रेस, गारंटी बाउंडेड वेट। अगर आप गौर से देखो ये सोल्यूशन, इसका ब्यूटी ये है कि जो दो सॉल्यूशंस मैंने प्रेजेंट किए, लॉक वेरिएबल और स्ट्रिक्ट ऑल्टरनेशन, वो इसलिए प्रेजेंट किए कि आपको बताना था कि हाउ ए कंडीशन इज टू बी टेस्टेड फॉर वायोलेशन और फॉर गारंटी। सर मैं समझा नहीं कुछ बात, समझिएगा। लॉक वेरिएबल को अगर आप कंपेयर करो स्ट्रिक्ट ऑल्टरनेशन से, पॉइंट नंबर 1, lock variable does not guarantee mutual exclusion, strict alternation guarantee mutual exclusion. Lock variable guarantee progress, strict alternation does not guarantee progress. Lock variable does not guarantee bounded weighting, strict alternation guarantee bounded weighting, दोनों इस लिहाज से ऑपोजिट है। तो मतलब मैंने आपको बता दिया है through these two mechanisms how to test satisfaction of mutual exclusion, failing of mutual exclusion, how to test failure of progress, guaranteeing of progress, how to test guaranteeing of bounded weighting, failure of bounded weighting, दोनों मैंने बता दिया. Even though both the solutions are incorrect, but my objective was to show you how the solution is to be tested for guaranteeing the condition or dissatisfying the condition. ये मेरा intention था. So how are we going to have a, so far we didn't set any correct solution. Then question is, under what circumstances are we going to have a correct solution? Correct solution क्या होगा? Correct solution will be attained by using the good features of lock variable and strict alternation, because that is, this is guaranteeing mutual exclusion, that is not. This is not guaranteeing progress, that is guaranteeing. This is not satisfying bounded weighting, that is not. So combine कीजिएगा दोनों को, and then we come across a solution which is called Peterson protocol, Peterson mechanism, Peterson solution. Peterson solution is also a software solution. It guarantee mutual exclusion, it guarantee progress, and it guarantee bounded weight. And it is limited to work, like with strict alternation, it is limited to work with two processes. It cannot work with more than two processes. Peterson protocol. And it is a combination of both. How? हमें discuss करना होगा, मैं आपको बताऊंगा. So maybe in the next lecture I will show you the working of Peterson protocol, because it may take another half an hour. So therefore, I don't want to elaborate this lecture for more time, so that you can watch the videos in a very comfortable way. So in the next session we shall take Peterson protocol. लेकिन उसका एक basic ideology आपको दे रहा हूं कि it works like the game of toss, the concept of toss in the game of cricket. Umpire would make a toss. People would say that both the captains, one captain would say head, another will say tail. जो भी event का outcome होगा, based on that the captain will decide batting or fielding. Similarly, here also we'll have the same concept. We'll use turn variable, and we will have a flag variable associated with both the processes, indicating whether the process is interested in critical section or not interested. अगर दोनों processes interested हो, तभी variable of turn, toss का concept आएगा. Toss is meaningful only when both the captains are willing for the same event. अगर दोनों captains batting चाह रहे हैं, toss is meaningful. अगर कोई एक कैप्टन कह रहा है कि सर मुझे बैटिंग पहले करना है, दूसरा कैप्टन कह रहा है मुझे फील्डिंग पहले करना है, टॉस का कोई मतलब ही ना रहा. करेक्ट? टॉस इज मीनिंगफुल when both the captains are interested in the same activity. Toss is not meaningful when they are interested in different activities. अगर एक कैप्टन कह रहा है सर हमें पहले बैटिंग करना है, दूसरा कह रहा है मुझे पहले फील्डिंग करना है, तो अंपायर बोलेगा टॉस की क्या जरूरत है, चलो शुरू कर दो गेम. तो अंपायर पहले पूछेगा भैया आप क्या चाह रहे हो, पहले बैटिंग, आप भी बैटिंग, चलिए टॉस. सेम मैकेनिज्म हियर इन पीटरसन प्रोटोकॉल. If one process is interested in critical section, other is not interested, there is no meaning of turn, there is no role of turn. If both are interested in critical section, then turn. So that's why I correlate, ये मेरा अपना perception है. The concept or the working mechanism of Peterson protocol is like the concept of toss in the game of cricket, hockey, football, whatever you say. लेकिन इसका एक लिमिटेशन है जो हम डिस्कस करेंगे या आप कर सकते हो from the textbook of Galvin, that Peterson protocol we say does not satisfy or does not work correctly on modern architectures and modern compilers. Modern architectures or modern compilers में ये problem है कि it can reorder the statements which are independent. अगर दो statements है which are independent, then for achieving optimization or efficiency, the compilers, modern compilers or the modern architectures can reorder the statements. तो Peterson protocol में हम देखेंगे जब reorder अगर हो जाएंगे two statements, it will fail to guarantee mutual exclusion. So that is the only limitation of Peterson protocol. वरना अगर आप if you take a architecture or a compiler which is not going to apply reordering of independent statements, Peterson protocol is an absolute correct solution. लेकिन उसके अदर लिमिटेशंस है Peterson protocol. Peterson protocol has a limitation that it can work with only two processes, and secondly it will also have busy waiting, and busy waiting का problem है wastage of CPU time. And thirdly, any correct busy waiting mechanism or almost all the correct busy waiting mechanisms would also suffer from a problem called live lock or priority inversion problem. Priority inversion problem hoga when the type of scheduling is preemptive priority based. If you are using preemptive priority based scheduling, we may encounter the problem of live lock or the priority inversion. Those are the limitations. And lastly, I would like to tell Peterson protocol is derived from another algorithm called Decker's algorithm. So Peterson and Decker essentially same way में work करेंगे, same way में work करेंगे. So what I suggest to the GATE aspirants is, after seeing these two mechanisms and also the basic introduction of the synchronization, I would basically appeal to you that you take up the PYQs and try to solve them based on these two mechanisms. There were at least, I would say, up to 5 questions which were asked based on strict alternation, based on lock variable, right? You try to basically work out those questions and check whether are you in a position to work out, are you in a position to basically analyze the code or not. देखो बच्चों, repeatedly I am saying, as you saw here in the lecture, synchronization is basically a topic which requires or deals with what I suggest, analysis. एक एनालिटिक फ्रेमवर्क आप में आपके माइंड में डेवलप होना चाहिए, ठीक है. अनलेस दैट फ्रेमवर्क गेट डेवलप इन योर माइंड, यू कैन नॉट सॉल्व प्रॉब्लम्स ऑफ सिंक्रोनाइजेशन. उसका सक्सेस स्टोरी यही है कि आपने वीडियोस जैसे हम यहाँ पर देखे हैं, यू ट्राई टू वॉच द वीडियोस अगेन एंड अगेन, ट्राई टू रीड द टेक्स्ट बुक एंड ट्राई टू मेक अ ट्रेसिंग इज वेरी इंपॉर्टेंट इन सिंक्रोनाइजेशन. जब तक आप मैन्युअली ट्रेस ना करोगे, और जो भी मैंने कहा है assumptions and then the way I have done the analysis, आप जब तक उस तरीके से अगर आप नहीं करोगे तो तब तक आपको प्रैक्टिस नहीं होगी. तो the key for success in synchronization is that a lot of reading, a lot of understanding and watching the video multiple times, and then doing the practice of analyzing the code multiple times, so that you get a grip, you get a grasp of the concept. ठीक है. So chalo, next class में we'll start with Peterson protocol. Take care. Thank you.